Okay, where are we? What was I doing? Yeah, wait. There it is. Now we need to learn to set, to move an image into a null array. We need to be able to copy images into the neural network. So this is what this function does here. Set image RGB. Set image there doesn't work. RGB. Okay, so the idea is to copy the image into the neural layer, but by putting it as a three-dimensional array with three separate layers of numbers, three separate depths, one for the R, one for the G, one for the B. Okay, so let's see how I would do this here right here. If parent equals 0 again, and also we have to set if image data equals 0. Okay, just remember, the data we're passing is the width, the height, and the image data. Okay, or image data equals 0, return 0. Okay, what else? Okay, if wait a minute, parent, no other way. Compare value. Oh, okay, I need to compare to make sure that the neural array shape is some specific value. I completely forgot about doing that. There it is. Okay, neural array shape, type shape. I need to make a modification here. Okay, type shape, where is it? Type shape, open shape. Why? Oh, it's here. Okay. Okay, type shape compare. Let's copy this right here. Okay, type shape compare with height depth. Okay, let's copy this right here. XYZ. No, come on. XYZ, don't do this to me. Okay, shape compare. Move. XYZ. Okay, compare XYZ. Target X. Okay, now we're comparing a specific shape to a specific values, to a specific set of values. Shape compare. Compare what should I call it? Compare value. That should work. Compare value XYZ. Okay, what was I? Type null array. Okay, type if. What was I again? Okay, type null array compare value. Okay, what was that? Type null array compare value. Okay, compare value. Parent dot array shape. No, and parent dot array shape. Let's not forget that. And parent dot array shape. Okay, image width, image height, and tree. The tree means three layers: the R, the G, and the B values. Okay. Okay, image height equals 0. Now we compare the shape, return 0. Return 0. Okay, now we make sure that it's the right shape. It has to be the same shape, it's the same size of the image, and it has depth of 3. Okay, next. Okay, next, what do we do? What's the next? Image data for I equals. We need three arrays here. What should the arrays be? Okay, we need 3 pointers in order to copy into under the array. So what should they be right here? Okay. Okay. Let's just do it. We'll figure it out later. For I equals 0, I less than we need to do the length. We need a length. Length equals image width times image height. Okay, we're just figuring this out here. Okay. For I equals 0, I less than length. I plus plus. No, where am I? I plus plus. Okay, now we need to copy the data into the image. Okay, so if there's an R, a G, and a B. Okay, I did this before somewhere. Okay, wait, I'm gonna have to find out where I did this before. Okay, there it is. I found it. Okay, this is where I did this before here. We need the color value equals image data dot index. Okay, so where was I here? Type neural network or type neural array. We need a color value. Okay, color. No, actually it has to be in here. Color. Okay, where is it? I keep getting lost. Ah, I'm getting lost here. Okay, color equals unsigned char image data. Okay, there am I. Color equals unsigned char pointer image data. Why don't I just say image data is unsigned char, but just to be okay. Where am I? A color dot I. Oh wait, color color dot. Oh, now I'm confused again. Okay, color dot. There's an ABC. Color dot 123. There's a 123. Okay, unsigned long. Unsigned long. A, B, C. So we have three arrays here. Okay, length A equals length times something. No, length times 0. Length times 0. It's useless, but this is just done to be symmetrical because I like everything to be symmetrical here. Okay, what the hell? A, B, and C. Length times 0, length times 2, and length times 3. Length times 1 and length times 2. Okay, so we're pointing to three separate buffers. Okay, color dot A plus I. So we're doing three separate buffers equals. No, that's not right. Okay, something's wrong here. Okay, something's very wrong here. We're copying into it. Okay, this is a pointer to where we need to be. To where we need to be at the RGB values. Okay, color dot I. Oh, so it's image data. No, new parent dot neural array. Parent dot array data dot so it's here. Parent dot array data dot I. Oh, I'm confusing myself completely here. Okay, let's do this again. Now we need to know where we are. Now I figured it out. Okay, unsigned long. No, unsigned. I, J, and K. I've done this before. I know this. Okay, I, J, K. For I equal J, J equal K equals 0. Okay, so here's what we're doing here. Parent.iData.a plus K. K is the location inside the array data. Now K is location inside each separate in each of the three separate arrays equals CUDA neural unit equal float color.j. J is the current location dot into color. Oh, we don't need that. Image data. We don't need color. We need just image data. Image data dot j. Actually, we do need color. We do need color. What am I doing? So I am being confusing here. Color equals image data. Is the color should be unsigned char. unsigned char pointer color. Why don't I just set image data to... No, this thing's really confusing me. I don't think we even need that. I'm confusing myself here. I'm just going back and forth on this. Okay, we need to figure this out here. Color, no, image data. I just set image data to unsigned char. Image data is unsigned char. That should simplify everything. Okay, image data dot j. Okay, so what should j be? J plus equals 4, because each long value, RGB value, has 4 bytes. So j plus equal 4 has 4 bytes here. And k plus equals 1. K plus plus, k plus equal 1, because each of the values here is 1 byte, but it has 3 separate arrays. So each one has a single value. Parent.age is a floating point values. Should it be floating point values? I'm not even sure if I set it to floating point. I did, but I should probably fix this later at some point. Okay, so let's copy it. A, B. So this is the B array, the A array, the B array, and the C array, or the C location in the array. So each one of them has this one. So it's the color value, and we have to divide it by 255. So, but we have set it, but we still need to cast it to get a neural unit. You have to cast it to a floating point value. And now we cast it to a floating point value. Get a neural image data. Okay. This is complicated, but we're getting it. Where are we? Okay, now we're getting it. Divided by 255. So we need the value between 0 and 1. Okay, so we need to value between 0 and 1 image data. Okay, that gives us the right value. Oh, so we're getting there now. We are getting there. I don't like the fact that image data is set to a floating point. It's set to a char value. Let's change it to something else. Unsigned char color. Okay, CUDA neural unit buffer. I like to be more flexible in this buffer. This is just to allow us to be more flexible. But a color equals unsigned char pointer image data. No, image data. Buffer, no, buffer equals CUDA neural unit Now the reason we need cast everything, we actually don't need to do it, but I prefer to stay flexible about this because we may want to change the type of the image data to something else. I mean, of the array data to something else later, and this is just safer to keep everything local. I mean, we have to keep it local just to make sure we can change everything to what we want later. Unsigned char, not unsigned long length, 32-bit value length. Okay, now we're getting somewhere. What am I missing? Oh yeah, buffer. Buffer.a plus k equals color. Color.j plus I divided by 255. Okay, j plus equal 4, k plus equal 1. Just to be clear. Okay, am I missing anything? Width times height. So I think we're done. Okay, if compare value, we make sure that the image is the right shape, then we cast the values, and then we select the offset into the three buffers. It's three separate depths, and then for each unit, we set the R value to the corresponding array, corresponding offset, R, G, and B. Oh, we're missing something here. This is wrong. This is very wrong. Okay, it's A equals 0, 1, and 2. But we don't use the I's anywhere. We should probably set that to I. We don't need K. Oh, we actually don't need K. Oh, forget about K. Okay, now that we've done the setting the set image, we need to copy this. We need to make a copy of the reverse of it. Okay, let's just copy and paste. Set image and get image. Keep everything else the same. Okay, just set everything else the same, except we have to reverse this right here. Okay, color. Oh, what am I doing? Whatever. Okay, color dot I dot everything else dot J1, J2, J3 equals buffer times 255. Except that doesn't work. Okay, we have something called max out. Okay, there it is, max out. Okay, I wonder if it's the same thing. Get image. No, it's not. Because here's here we have to live from 0 to 55, but here it's from 0 to 1. From 0 to 1. Let the image max out. Array max out. Okay, I'll just call null max out. Null max out. Okay, null max out. Buffer times 255. Okay, set everything to 55. No, buffer times 255, not divided by 255. Buffer times 255. Okay, that should do it. Okay. Make sure everything's right. Otherwise, this should be the same thing. A plus I, no, B plus I, and C plus I. No, C. Yeah, sure. Okay, null max out buffer times 255. And we just take everything we did here and then just reverse this part right here. So that's really all we have to do. Also, we have to hope that we didn't make a mistake. Okay, let's see if it works. Okay, let's go back here. Did I copy all this right? Okay, we have to get the image. Okay, type the neural array. We need a neural network, neural array. Array source. Source, and we need a second one called result. Okay, let's just hope we didn't make a mistake. Type neural array create. Okay, let us copy and paste because I really don't feel like moving this. Did I save this? I saved it, right? Yeah, I think I saved it. Okay, type neural array create. Okay, where are we? Type neural array create. Let's just hope we don't make a mistake. Type neural array create and source. Okay, image weight, image height, image 0, image weight, image height, same thing as here, and 3. Image weight, image height, and 3. Result is same thing. Image weight, image height, 3. Okay, get image. Okay, type neural array copy. This won't confirm that we get it right, but it should be a good enough indication. Oh, shoot. What am I doing? Type neural array set image RGB and source. We have to copy it. image width, image height, image data. Did I get that? Yeah, image width, image height, image data. Okay, type node array copy. It won't confirm that we got it, but type node array copy and now result source and source. Okay, result from source. And last, could a node array get RGB. This will not confirm that we got it, but again. But oh wait, we can't do this. We can't do that. We can't do that. We cannot do that. We copy the image into image 1 or image convolution. Okay, set it down here. We take this image and then copy into this one and then copy it back into not source, result. We get our result. We get it from result and then try to display it, see if it works. And build. Hopefully we didn't make any major mistakes. Yes, we did. I'm gonna have to fix those. Okay, here are a few stupid mistakes. I set type neural unit to, I forgot to set it as a pointer. Okay, I just forgot to set it as a pointer. Now save everything and try rebuilding, see if it works. Oh no, still. We got a few errors again, and let's try to fix those. And a few small mistakes again. Here we forgot to convert to unsigned char. Unsigned char. Okay, unsigned char max out. Okay, 1. Okay, that makes a mistake here. Okay, that's a huge mistake. Neural max out only applies to buffer. It doesn't apply to the multiplication. Oh, that's a stupid mistake. If you just multiply it, if you apply neural max out to buffer times 255, you get a value that's limited to just 1, which is completely wrong. Those are a lot of small mistakes that you have to correct. Oftentimes, it can take several days to even figure out where you have an error. But hopefully, I get it right this time. Okay, now to run it, see if it works. And it doesn't. We made a huge error somewhere. I'm gonna have to fix that too. Okay, I just discovered something really stupid again. Optimizations are still turned on. I thought I turned them off, but now they're back on. And it's not compiling all the code. Okay, cancel. Let me show you what happens here. Because I'm not sure if I make this clear before. What am I doing? Now let's see if it's still not showing up. It's still not showing up. Oh yeah, it's just messing up the code completely. Build projects. Turn off optimizations when doing release. Favor speed. That's just really stupid. Optimization just refuses to compile some of my code. That's just something about Visual Studio I just don't understand. Why would it do that? There it is. It doesn't work. It kind of works, but there's a mistake somewhere, which I'm going to have to chase down. I think I found the error, and it's really, really, really subtle. It's right here. It's one of those really stupid errors that you could spend hours or days chasing down. But it really, unless you know what you're looking for, it's not obvious what's going on here. Here I'm casting a neural max out to unsigned char, but it's supposed to be a floating point value. Yeah, if you cast it to unsigned char prematurely, it becomes something a byte when it's really supposed to be a floating point value, and that's the solution. If you don't know what you're looking for, it's really not obvious what's going on. If you don't know programming, that's you could spend days staring at this and never realize that you were looking at a major error. It's one of those things that really, if you're gonna do a lot of programming, that's one of those things that really messes you up. Okay, where am I? Okay, let's try this again. It's really not obvious at all. Okay, it works. We are able to send data into the array and send it out again. And let's review what we got. We copy the image. We copy the image by setting up trees. We have the buffer, but we have to set it in three separate. We have to split the buffer into three separate arrays. Length times 0, which is image width, image height times 3. Length times 0, length times 1, and length times 2. Same thing here. And then we copy the values R, G, and B. We divide it into bytes, and then each 4 byte it will represent RGB value. And then the first one, the second one, and the third one, and we copy in the corresponding array. And then we call everything, and it works exactly the same way. Now that we have this, next time we're gonna have to do something slightly different here. We have to apply all the image function like convolution and rotation, and then convert them into neural array functions. Basically the same thing we did with image, now we have to do with neural arrays. And once we can do that, then we're ready for convolution and other complicated stuff. Okay, next time.